Welcome to the using C# source generators to build a .NET IoT device. I think that the best way to start is to start with some code. So let's move to Visual Studio and let's create a project. And we'll choose console application. We'll give it a name, my IoT client. This is the code that will run in the device. Let's do next. And we pick .NET 7. You can also pick .NET 6 or 5, but I choose the latest version. And now Visual Studio will just create a simple console application, the simple Hello World application. And we will just delete all the text in the file. And let's give it some time. And now we can start write our code. So to write code that build an IoT device, what we will do is we will add two NuGet packages. So manage NuGet package, and we will choose the IoT hub generator. So there are two packages. There is the IoT hub generator itself, and there is the IoT hub generator SDK that allow you to decorate different part of your code using attributes to inform the code generator to generate source code for you. So we added the generator, and now let's also install the SDK. So once we install these two packages, we can start write some code, and we can create device using .NET and C#. So let's go to the program CS, and let's add a class. So let's say we want to add a public partial my device partial class, of course, class my device. And now it's just a class. It has nothing, but to ask it to start creating code for us, we can decorate it with attribute, and we will choose the IoT hub attribute, and also we will add the namespace, the using namespace. So now everything is okay. And if we will go to the my device class, and we can see the other part of our my device, and the other part is some code that was generated for us. You can see that there is a device client here that uses connection string that coming from environment variable, and we see also that we have an init IoT hub client async that call this create device for us. And to make it easy to see the changes, what we can do is we can drag this window and put it side by side with our code. So now we can start creating our device. So outside of the device, we can create our class instance. So var my device equal sign new my device, and we can await call to init IoT hub client. Now let's add some properties to our device, and later we will see that you can use the cloud to configure the device, and also use the device properties to inform the cloud about the device state. So to do so, we can use properties and fields, and we can decorate those property and fields and have code generation for them. So for example, if I want to report a property to the cloud, I can decorate a property with reported property, okay? And you see that I can give it the local property name and the twin property name. So, and this is decorated field. So the local property name going to be, let's say we want to report our battery level. So local property name will be battery level. And cloud property, usually we use JSON-like property, so it's going to be a camel case battery level. And now we will give it a field which is we can enter and give it something like private int battery level. And when I do it, you can see that now we have another function, which is the reported property that reports this property to the cloud. And we also have a new battery level property. And whenever we set this property, we also report the property value to the cloud. And if I change the name, you can see that the name is changed immediately. Let's do an undo. Okay, take a bit of time, but then the change is name. So this is, for example, reported property. If I want to have a desired property, so you set something in the cloud and it's you get the value, the replicated value to your device, you can set desire property using the desire attribute. And again, you can give it a name, but you don't have to, because the name of the property is going to be the name that you use also in the cloud. So for example, let's say I want to change the reporting time on the reporting interval. So public int report interval get set. And once we have it, we can see that now we also have support for desired properties. So handle desired properties, and you see that if the desired property contains reported interval, we parse the context of the data and we assign it to report interval. So this is the code that you write, this is what you get, and this is the power of the source generator. If you want to send telemetry to the cloud, you can go to this attribute, tell it that you want also to add generate send method and give it a name, send telemetry async. Okay, I have a typo, telemetry async. And now you can also see that we have a function which is a send telemetry function that you can use to send any payload as the data coming from your device. So we saw sending telemetry, we saw that you can set reported property to inform the cloud about your state, and we saw that you can set desired property so the cloud can change this value and it will be reflected to your class. And there are many other options of IoT Hub that you can use attributes to decorate your code, and then you get everything for free. So all the boilerplate code is the code generator generates for you. So with that, we can move now to some of the theory part and talk a bit about IoT and the IoT Hub of Azure, and also about code generation and how we can create or how you can create your own code generation, or if you want to join my project and assist me with adding more feature to the project, you are welcome. Okay, so to make such a system, we need an IoT device, and we are going to use the Raspberry Pi 4. We are going to use .NET 7 and some .NET IoT libraries that I'll show you. Of course, CSharp source generator and the Azure IoT Hub. Both the service SDK to control everything from the cloud, and the client SDK to create the device. This is actually the code that you saw using the source generator, and Visual Studio and VS Code. So I didn't tell you, but my name is Alon Fliss. I'm a CTO and founder of Zionet, a software house of young developers. I'm also a Microsoft Regional Director and a Microsoft Azure MVP, and I'm a maker. I build stuff, I build things like this. I build it from scratch, so using 3D printer to print the box. I design everything, I create the electronics, and also the code. And today we will focus about writing code for devices. So an IoT system or the IoT 101, you need a device. The device must have a way to communicate or to connect to the web. You need to sense the world, so you need to have some sort of a sensor like this, like the one here that can sense temperature and pressure. And combine everything, you get an IoT system. And of course, you need some code, and this is what we'll see soon. So the device, there are many different IoT devices. Some of them are very low capability device. So you must use C code, for example. But some of them are pretty rich, like Raspberry Pi. This is like a small PC. And here you can run almost everything, including the .NET framework. And this is the device that we are going to use. To sense the world, you need some sensors, and to activate the world, you need some actuators like relays and engines, motors, and this kind of stuff. So you connect them using electronics to your device. And sometimes you don't even need to understand electronics. Sometimes it's just taking some hardware building block, connect them together, and you get a system. And there are so many examples on the web that you can find how to build those devices, that even if you don't know how to work with electronics, you will be able to create your own device, your own system. But IoT is more than just the device itself. IoT, when we talk about the Internet of Things systems, we talk about usually a system with many devices, sometimes different devices. They can connect directly with the clouds, or they can use a gateway device. You need to collect lots of information. You need to register the device, to management the devices, to control them. You need to support many different communication protocols. Sometimes you have smart edge devices that can run uh, much more complex code, like the Raspberry Pi, for example. And then you need to collect information, and usually it comes to lots of information, and you need to move it to the cloud. So you need some sort of a data pipeline, and then you need to analyze the information, and you need to extract real-time information, and also you can use machine learning and big data analysis to extract some other uh, um, outcomes of the data that you collect. And eventually you need to do something with the data. You need to show, you need to have a conclusion from the data that you collect. And for all of these features, this is why we need the cloud. We need the cloud to support the devices. We need to have a secure communication, all the things about registration and management. And this is on Azure, this is what we get from the IoT Hub. And also you need the cloud for your system, for your application, for your analysis, and so on. So typical IoT solution, we connect different IoT devices either directly or using a gateway. Then we have this Azure IoT Hub as the central point, or as the main service that knows how to manage those device, and also taking care about the secure communication. And then Azure IoT Hub can move the data to other location, other services in the cloud. Also, Azure IoT Hub supports um, managing the device. So you can think about it like a device registry, and managing the identity of each device. We have like an entry for each device. There is also the device state. You saw these two properties, the desired property and reported property, that reflected the state of the device. We call it the device twin, and the IoT Hub manages the twin. And you have other services like Azure Stream Analytics that knows how to or let you create queries against the stream of data that comes from the device, all the telemetry that you send from the device. And of course, all the other services. So you can run Azure Functions, or you can host your code in containers, or whatever you need to do to work against the data, and of course all the analytics capabilities of the cloud. So we want to focus on the IoT hub, and the IoT hub lets you do all the things that you need to do against the cloud from the IoT point of view, the IoT device point of view, and also let you manage everything from the cloud point of view. So you can connect to the cloud, you can send device to the cloud messages, you can receive messages back, you can get update or send update about twin properties, those desired properties and reported property. You can get a direct call from the cloud. So I can from the cloud, from a cloud service, I can call your device and activate a function in the device and also get a result. So request reply can be done. Also, you can send messages to the device and the device will get the message, like queuing a message, and also sending telemetry from the device to the cloud. You can create long-running jobs and manage them, like updating all the desired properties of many different devices. And you can query for devices, query by the device tags or by properties. And you can route telemetry from the IoT hub to other cloud services. And we will see it in our demo. The device twin, this is the like a NoSQL DB for all the devices that are registered to the cloud. So you can see if the device is currently connected. And you can also set different properties. You have the desired properties, so you change them from the cloud and they will be reflected, the value will be reflected in the device, or you can change properties in the device and the value will be reflected to the cloud. Things like the version and the battery level and the current state of the device can be reported. Things like the reporting interval or anything that we want to configure in the device, we can set in the desired part. We can also query this device twin database, and we can also use the query language to route messages from the device to other services in the cloud. To work against IoT Hub and to create your device, you use some SDKs, and you can see that there are many different SDKs. Each SDK can support different programming languages and also different hardware devices. And in our case, we are going to use the .NET SDK or the CSharp SDK, both for the client and the server, and we are going to use the Raspberry Pi for our system. Routing telemetry, you get a message from the device, the telemetry message, and then you can have a query, and if the message answers the query, you can route the message to one of the other cloud services. For example, in our case, we get a message and we route it to Azure Service Bus, and from the Service Bus, we will be able also to call back the device and do something with the device. To develop IoT solution using .NET, there are two packages. There is the system device GPIO, and there is the device binding. You can think about them as the lower level package, so it communicates with the IOs, it knows different protocols, hardware protocols, and the device binding, which is a collection of devices that so this package knows how to communicate specifically with different families of devices, sensors, screen, input devices, and so on. And this device binding package or library sit on top of the system device GPIO. So if you just need to change the level, the voltage level of a line, you can use the device GPIO. But if you want to control a device, it would be much easier to use the device binding. So this is about how you can use .NET with IoT devices. Let's talk a bit about the source generator. So you've already seen the magic of how to use the source generator, but let's talk about what is actually a source generator. So it's part of Rosling. It came in C# 9, and you generate source code, and you saw that what you generated is a C# file. So the resource to generate the code can be your code, like we use our code and we decorated it with attributes, but you can have other files. You can take text file or CSV files as the source for the code, and then you can create C Sharp code. The file that you created becomes part of the compilation, and the compile eventually will compile the original source and also the source that you that is created from the source generator. There are two flavors for the source generator. There is the original one where you need to implement the iSource generator interface, which is somewhat simple or simpler approach than the other one. And there is the one that came in .NET 6, which is the incremental generator, and it's supported only from Visual Studio 2022. So if you want to support both Visual Studio 2019 and 22, you need to stick with the iSource generator. But if you want to support the new way of generating code, you need to create the incremental generator. And they have different philosophy of how to create code. The iSource generator is a very simple approach. You just register your code to get the syntax tree of the code, and then you get calling with the syntax tree, and then you can extract information from the syntax and the semantic code, and in the execute part you create the code. While the incremental generator is a bit more complex. You don't register to anything. You need to go through the code and you need to create the generated code in several parts. So the high level image, you have your C# source file. There is also the source generator package that you install. The C# source file get parsed by Roslyn, the C# compiler. Then there is the syntax tree of the file that was parsed, and then there is the compiler, and the syntax tree get compilation. Using the information from the compiler, which contains both the syntax tree and the semantic, you can start doing the source generator. So you go and ask for all the attributes in the code, all the classes in the code, the different fields, different properties, and using this information, this metadata, you create your own text file. Once you created the text file, then you submit it back to the compilation, and it goes the same stages. So first we have the C# syntax tree, then we have the compilation, and eventually all the files will go to emit IL code, and this will create your DLL. So how do you start building C# source generator? First of all, you need to read and see more lectures because this is just an overview. But the main thing that you need to do is to create the generator class. You need to implement, for example, if we go with the new one, the incremental generator, so you need to add the relevant Roslyn packages, and you need to implement the incremental generator. Then you need to analyze the input, all the semantic model, the syntax model, and create your own model of data only for the data that you need. And then, since you use the incremental generator, you need to design a pipeline. So in the incremental generator, you have many different stages, and you can think about the different properties and attributes as things that you can run in parallel. So if we'll go to this documentation, you can see that when you create an incremental generator, you basically create some sort of a pipeline and with many different stages, and each stage can generate something else. So for example, each desired property can be generated separately, and then everything can be combined. And this is the difference than the original generator, that everything was generated at one place or one piece. The reason to go with this approach is that the incremental generator knows how to cache the output of each stage, and if it sees that there was no change in the source code that's related to a specific stage, it will not execute the stage. It will take the old cached result, which makes it run much faster comparing to the old generator. So if you target Visual Studio 2022, you should create an incremental generator. You should read this document and also may see some other talk about source generator, and then eventually you can create your own generator. So you create the pipeline, you take into consideration the caching when you split to different stages, and then you initialize and the code, get all the information, generate the code, and then of course you need to test and integrate the code. Will you be able to see the code that you generate? So you saw, I showed you that you can see the code during editing, but you can also ask, in your project file, you can also ask to keep the file itself so you can see the generated file. What you can do with source generator, anything which is boring to write or is tedious to write, so you can automate many things. You can swap between runtime reflection code, so instead of spending the time in runtime, you can spend the time in compile time. Automate processing, and as I said, remove all those boring typing, and easily create Azure IoT Hub client. What about debugging? So you can debug the code. There are several ways to debug. One way is to use a generator driver. So this driver can generate the code, and then you can use the code itself. For example, in my source generator, the IoT Hub, I have tests that use the generator driver. I create the code and I use approval to compare the created code with the approved code. So I just compare text, and then I can see that the generated code is the one that I wanted to create from the beginning. It also gives you a nice way to do debugging. If you use debugger launch, it means that you are going to debug Visual Studio, because Visual Studio is the one that hosts your code. You can also set source generator debugging. So when you create your demo code or your source code, you can set that the debugger will be Rosling, and then you will be able to do a single step on top of your code instead of the code that is going compilation now. So let's talk a bit about the IoT Hub client generator. So it's an open source project. It's on GitHub. It still uses the old iSource generator. It supports both Visual Studio 2019 and 2022. And let's see the project itself. So this is the solution, and again you can go to GitHub and see the solution. It has everything. It has the source generator itself with all the functions and classes to create a different part of the code. It has a demo, which is just a device that the same as I showed you, an IoT device with all the different parts. It also has testing, so you can see the different tests, different test case that you can, and a test runner that runs the different tests, and also all the approval files. So these are the result files from the generator that you can, that it compares the generated code with these result files. And it also has the GitHub action files to deploy and test it on GitHub, and also to deploy it to NuGet packages. So whenever I change it, I just run the action, do a release, and it automatically deployed on GitHub, on NuGet.org. Okay, you can also find the project on the web. So if you go to GitHub F, you can see the project, everything is here, and you can see the actions, the different releases, So you can find everything here. Okay, so let's see some demo using the Raspberry Pi. So to use the Raspberry Pi, you need somehow to connect to the Raspberry Pi. So I have this. Um, Let me take my phone as another camera, and let's move to the phone camera. So I have this Raspberry Pi that comes with a keyboard. Okay, but this is just the same as this Raspberry Pi, and you can see all the wires that are connected um, to the Raspberry Pi, and uh, I also have some devices connected to the Raspberry Pi. So I have this lights, this LED strip. I also have this matrix of LEDs connected to the Raspberry Pi, and I also have the sorry this what is this sensor which can sense humidity and pressure and temperature. Okay, and let's switch now also to see the and the Raspberry Pi itself. I use this HDMI capture device, so I can use my screen, my PC screen, to see the Raspberry Pi. So let's now switch also to Raspberry Pi itself. Let's move the mouse. So this is the Raspberry Pi, and here I have the code, and I can you can see that you can use VS Code also with the Raspberry Pi, so you can even write the code in the Raspberry Pi itself, and um, I can just do .NET. You know what? Let's move now to see the all different sources. So we have the Raspberry Pi, we have our lecture also, and we have the camera. And now let's just do a .NET start with on the Raspberry Pi. So let me type .NET run. Okay, and it should start. So we can see that it started, and we also want to run some client code that control or communicate with the device. So let's have our client demo. Okay, let's bring it to this screen. Okay, and let's just run it. So this is a very simple application that communicate with the device. Okay, let's move it to here. You see that the device, the client is connected, the device is also connected. You see the different measurement that comes from the device, and now we can do some actions. So for example, we can start this this effect, okay, or we can choose something else like this one, and we have this marvelous lights. We can let's stop it, and we can for example let's send a message like hello WID. Okay, and it should be on this screen, so let's send it. Okay, cool. And we can also change the temperature or the humidity using this device. So I will blow on it. and we should see, okay, you can see now in the screen that we get different humidity, and also probably the temperature will go a bit up. And we can also send it to the display. So send this value. So this is the temperature, and this is the pressure, and this will be the humidity. So you got the ID, and there are some other nice effects like the rainbow effect that we can start. Okay, cool. So let's stop. Let's move to the screen scene. All right. So let's stop it and let's see some code. So to control the device from the cloud, or in this case from the machine, we use the service SDK, and then we can get the connection string for the IoT hub. Also, we use service bus to get the measurement from the device. So you see, create from connection string, open the connection, and then we can work against the device. So start effect, we create a message, and we send we actually call a direct method in the device, and so you can later go and look at the code and see for yourself. And this is the device code that gets the different messages. So this is the IoT device, and you can see that we have reported property about the brightness, so we can change the brightness of the LEDs from the cloud. We have we have so we can set the it's reported we change the brightness and set it into the cloud. This is the report intervals from the cloud. This is my device client. This is the device coming from the .NET IoT SDK about the sensor, and this is for the LED matrix, and this is for the LED to the LED strip. So these are the different devices. You see that we send data, reading the data from the sensor. So we read the information and then we serialize it and send it to the cloud. And this will go to the generated function that send the data. For some reason it does not show it, but this will go to the generated function. So again, you can go later and see the different ways that I communicate from the cloud with the device, or when the device gets the information. In the cloud itself, you can find, let's go to the portal. So on Azure, you can see the IoT hub. So in a second, so let's go to here. Okay, this is the IoT hub itself, and in the IoT hub you can see the devices. So you see the different telemetry that I send. You also see the devices. You can see the Raspberry Pi device. Actually, now there is only a single device. So this is the Raspberry Pi, and you can see the device twin. And in the device twin, you can see that the device is now connected, and you see the reporting interval as a desired property, and you see the LED's brightness as a reported property. So this is the device twin. So let's summarize the lecture. So So what we've seen is that using source generator, it makes it easy to write code, and I showed you this open source project that I created to develop IoT device in C# using the Raspberry Pi. So now I think that you can take whatever you saw here, go to my GitHub, go to other resources, and start play with IoT devices and Azure. Thank you very much.